So this is Yadagiri working as assistant professor in Triple department in Marri Laxman Reddy Institute of Technology and Management. So today I'm going to discuss about the second module, that is single phase AC circuits. So in this lecture today I'm going to deal the introduction to the single phase AC circuits. So in previous lectures we have seen, in previous module we have seen the concept of DC circuits. So what is the difference between DC circuits and AC circuits, and how the DC is converted to AC, and what are the advantages of AC over single phase system. So that we are going to see for today's class. So let us see the introduction first. So in day-to-day life, so we use electrical power system for various applications, which is including the domestic and industrial applications. So all our applications, whatever the applications we have seen for domestic and as well as industrial and also agriculture purpose, we can use the AC supply compared to the DC supply. 90% of the electrical appliances we are using as AC appliances only. So that's why we use in our day-to-day life, we are using electrical power in various applications. So most of the domestic applications we use single phase AC supply, whereas for high industrial and agriculture purpose we can use three-phase AC supply. So what is the difference between single phase AC and three-phase AC, we will discuss coming classes. So certain domestic applications such as telephones and the DC supply is used here. So certain applications we will require sometimes DC also. So there we can convert AC to DC with the help of the rectifiers. For certain applications such as an electric trains, so high voltage DC system is used. So this is the one application we can use here. So now we will see what is the difference between AC and DC quantities. So here in this, see the waveform first. So first here, the quantity which is changing periodically with respect to time. So you can see here the quantity is changing periodically with respect to time. So from the instant to instant its value will be changes here, and it is this quantity is changing with respect to time here, and we are seeing it is positive half cycle and negative half cycle. So this is one complete, we can say one complete cycle here. So this cycle is repeats here. So from waveform point of view, we can see that the waveform is alternatingly changes with respect to time. Whereas here in case of DC quantities, the magnitude, the quantity is not changing with respect to time. So the quantity means either voltage or current. So it is not changing with respect to time. So here it is, the magnitude is fixed here. So direction is not changes here. So magnitude and direction is not changing with respect to time. Then we can call it as a DC quantities. So we will see the definition point of view also. So it is a signal which changes its magnitude as well as polarity in case of AC quantities, and in case of DC quantities, so which changes its magnitude but does not change its polarity here. So magnitude is only changes but its polarity is not changes in case of DC quantities. So here we can, in case of AC quantities, we can use the transformer. So the transformer is used to step up or step down the voltages, or increase the voltage or decrease the voltages with the help of the transformers. So it is possible in AC supply, whereas it is not possible in case of the use of transformer is not possible in case of DC quantities. Coming to the efficiency point of view, so we are having highest efficiency in case of AC systems compared to the DC systems. So in the DC quantities we are getting the low efficiency compared to the AC systems. Next point, we will see the next parameter, that is design of machines. So in case of AC we are easy to design the machines, and here in this AC we are using the AC supply, so the absence of brushes and carbons were not used here. Whereas in case of DC, it is the circuit design is very complicated, because here you are using the commutator segments, brushes and etc. So that's why the design of the machine is not so easy in case of DC quantities. So whereas it is easy in case of AC quantities. Next, the generation of AC quantities is very easy in case of AC power generation. So from the AC waveform using commutator we can convert, or commutator or rectifier we can convert that AC to DC. So that we can say that the generation of AC is very easy compared to the DC. So where DC, wherever the application is required, we have to convert that AC with the help of commutator or the rectifier. We can convert it and we can use it. Application point of view, we can use that AC in AC motors, domestic and industrial supply, etc. Whereas in case of DC quantities, we can use it in DC machines and HVDC transmission, that is high voltage direct current systems, we can use for the DC quantities. So now let us go for the next one, that is what is electrical power system. So the electrical power systems can be subdivided into three subsystems. So they are generating system, transmission system, and a distribution system. So the electrical energy generated by the generating system is transmitted to the load center by transmission system. So whatever the power is generated at the generating station, that is used to transmit to the load centers with the help of the transmission system. So the energy is then distributed in the distribution system. So here I will give one simple diagram here. So here power is generated at generating station. So this power is transmitted to the transmission lines and it is distributed to the load centers. So the electrical power systems is mainly classified into three subsystems. First one is generating station, generating system. Second one is transmission system, and third one is distribution system. Okay, it is distributed, the energy is distributed to the distribution system. So the function of generating system is to generate the electrical energy. The input to such a system may be thermal energy, maybe hydro energy or nuclear energy. So the generation is it is a mechanism to generate the AC voltage, that is alternating current system it is generated. So with the help of the energy systems which may use as thermal energy, that is heat energy it will be used, and hydro energy and nuclear energy. So these energy we can convert into electrical energy. So we can, with the help of the power stations, so like thermal power stations, hydro power stations and nuclear power stations, we have to generate the electrical power, electrical energy. So the generating systems are broadly classified into two types. One is conventional system and another one is non-conventional system. Now let us see what is conventional system. So conventional systems are those which are non-renewable sources of energy as the raw material. So they are non-renewable energy sources. So the examples for the conventional systems are thermal systems and hydroelectric systems. So converting heat energy of fuels like coal, petrol, etc., we can utilize this. These are non-renewable sources of energy. So we can utilize this coal, petrol into an electrical energy. Similarly, so hydroelectric system. So hydroelectric system is also, it is converting the potential energy of the stored water into electrical energy. So in this way, we can see one more system also, that is nuclear systems and diesel electrical systems. So here the nuclear systems, it is converting heat obtained from the nuclear fission reaction into the electrical energy. Whereas in the diesel electrical system, so it is converting energy stored in the diesel into electrical energy. Next one is a non-conventional systems. So non-conventional systems are those which are renewable source of energy as an input. So non-conventional systems are classified as solar energy, wind energy, tidal energy and energy from biogas. So these are all the examples of the non-conventional systems. So by this non-conventional systems also we can generate the AC voltage, alternating current or AC energy. So we can see what are the advantages of AC system over a DC system. So high voltage can be built up here. So we can build up means with the help of the transformers. So we can increase our voltage from one level to another level. Okay. So next one, the fluctuations in the voltage levels as per the requirement can be done with the help of step up or step down transformers. So this increase of the voltage or decrease of the voltage can be done with the help of the transformers. So that is the beauty of the AC systems. We can increase voltage or we can decrease the voltage. Maintenance cost of substations and generation cost of AC voltages is also less. Okay, maintenance cost of substation, generation cost of AC voltage is also very low. The motors used are simple in construction and have low maintenance. So whatever the motors, AC motors are there, so that are simple in construction and have less maintenance. So maintenance of substation is also very cheap. And one more advantage is also there. So that is the conversion of AC is easy with the help of the rectifier. So with the help of rectifiers, we can convert AC to DC. So these are the advantages of AC system. Coming to the disadvantages of AC system, so that the initial setup is very expensive here, and the resistance offered by the lines is very high, so which causes skin effect, especially in transmission lines, and thus leading to the voltage drop. The AC lines are more sensitive to corona. The AC lines even show less losses due to the reactance offered by the lines. So the speed of alternator requires to be controlled. So these are the drawbacks of disadvantages of AC system. Now next we will see next one, that is utilization of electric power. So we can see some of the applications of electric power. So it can be used in domestic applications such as lighting purpose, fans, heaters, irons, TVs and etc. So we can use AC and DC motor drives, machine tool applications, electrically operated vehicles, that is EVs, trains, cars, welding purpose, so induction heating and dielectric heating purpose, and electro-agro systems. So these are the applications, or we can say that utilizations of electrical power. Now we move on to the next one, that is the fundamentals of AC systems. So we will see that the AC supply system. So the electric supply is used for domestic applications is single phase AC supply, whereas that is used for factories and institutions etc. We can use the three phase AC supply. So you can see in the diagram, so it is a AC supply, it is consisting of the two wires. So that is it is called as, so here two wires are there, it is phase and neutral. So one is phase, we can say this one is phase and another one is neutral. So in figure 1 we can see that this is a AC waveform. So it is alternatingly changing from instant to instant with respect to time. So waveform, what is the definition of waveform? So waveform is a graph of magnitude of a quantity with respect to time. Is a graph of magnitude of quantity with respect to time. The quantity plotted on x-axis, we can see on this x-axis is time, and the quantity plotted on y-axis will be the voltage, current or power etc. So on x-axis we can plot the time, so on y-axis we can plot the voltage, current or power. So This is about the waveform. So it is continuously changing with respect to time. So here it is a sine wave is there. So now we will see the different types of waveforms, different types of AC waveforms also. So here also it is AC in nature, but the shape is different here. So the shape of an alternating AC quantity need not be always in the sine wave. So it can be in other shapes also, such as triangular wave, square wave, or trapezoidal waves. So all are changing with respect to time, but they are not need not to be in sinusoidal waveform. So they are changing with respect to time as a rectangle, square wave, triangular wave, okay, trapezoidal wave. So like that they are changing. They are also changing periodically. So graphical and mathematical representation of sinusoidal AC quantities. So let us look at this diagram here. So it is a sinusoidal from instant sinusoidal waveform here it is. So here it is one complete full cycle here. You can see it will make positive half cycle and it will make negative half cycle. The quantity which is having magnitude and direction, it is changing with respect to the time. So positive half cycle and negative half cycle. Each half cycle is divided into pi radians or 180 degrees half cycle. So complete cycle it is divided. One complete cycle we can say it completes one cycle when it completes one revolution. That is 2 pi radians or 360 degrees. So now we will see the mathematical representation, how we can represent this graphical form of AC quantities in terms of mathematical representation. So the voltage waveform is mathematically represented, that is V of t is equals to Vm sin omega t. So that is omega is nothing but angular frequency, so which is equals to 2 pi f naught into t. So where V of t is nothing but the instantaneous voltage and Vm is nothing but the peak or maximum value. So whereas f naught is the frequency in hertz. So we will define these terms, the frequency, time period, amplitude, peak factor and everything we will define in the next lecture. So this is f naught is nothing but the frequency in hertz. So the sine represents the shape of the sine wave. So this is the standard and the mathematical representation of a waveform. So that can be represented in mathematical form. So that is this V of t can be represented, this quantity, this waveform can be represented in mathematical form, that is V of t is equals to Vm sin omega t. Omega is nothing but angular frequency. So it can be also represented as V of t is equals to Vm sin omega t or Vm sin theta also we can represent. So where theta is nothing but omega naught into t. So omega naught is nothing but angular frequency, that is equals to 2 pi f naught. So similarly, we can represent the waveform in the mathematical form, the current waveform in mathematical form also. So that is current I of t is equals to Im sin 2 pi f naught into t. So I of t is nothing but the instantaneous current and Im is nothing but the peak value or maximum value. So f naught we can measure in frequency, it can be measured in hertz. Okay. So these are the references. So thank you.